Hello and welcome back to California Geology. I am Dr. Robert Lopez. Today I want to continue on with the accreted terrains of Western North America. And if we look at the PowerPoint here, another thing I wanted to point out is that, again, the margin of North America, all the way from Alaska down into Mexico over here, is a series of these exotic accreted terrains. So we've talked a little bit about the Sonoma terrain. If you go up into Washington State and up in towards Alaska and Canada, you have the Alexander terrain, this Rangelia terrain. There's another one up here called Cache Creek, Stikine terrain, Koyukuk. There's a variety of terrains up here. But all these share one common characteristic, and that they all formed elsewhere and have since been tectonically docked or emplaced by motions along the Pacific margin here. Now, I'm going to focus on the Sierra Nevada and to some extent on the Klamath Mountains. And in the Sierra Nevada, this is figure 8-25 from chapter 8 on the Sierra Nevada. And in this northern part, going basically from the Stanislaus River, maybe a little bit south of that, up to the Feather River, which includes from the town of Auburn, here's American River, Nevada City, Yuba City up in here, Sierraville up over here, Sierra City up off Highway 49. This also includes in part the Mother Lode Belt. So later on when we talk about gold, we'll talk about how these terrains, or these oceanic settings, are really responsible for bringing the gold to California. But we'll look, and usually the terrains seem to be older from the east and get younger toward the west because they're documenting the initial docking. The older ones are docked or attached first. The next one's accreted after that, and then the youngest one's going to be farthest to the west. So if we look at the shoe fly complex in the blue that I've colored here, and the Northern Sierra terrain, they're farthest to the east, and they're going to be the oldest. In fact, recent work has really combined the shoe fly and the Northern Sierra terrain as one block. The shoe fly being the cratonic sediments on marginal Western North America, again related to that trailing continental margin. And the Northern Sierra terrain being those island arc rocks that were attached and thrust over the top of this shoe fly complex. And then there's a series of fault lines, ultramafic rocks here, probably ophiolites, again documenting that oceanic subduction zone accretion, where you in part sometimes this is called the Calaveras shoe fly fault, where you juxtapose the Calaveras formation. Here I've colored in kind of orange, this middle unit, which is about Permian Jurassic in age, and again both the Calaveras and the Northern Sierra terrain shoe fly complex have that McLeod faunal affinity. And then there's this major fault line here called the Maloney's Fault Zone, again outlined by these ultramafic rocks down here, especially in the south, that separate the Calaveras complex from the foothills terrain and that Smartville complex, the Smartville ophiolite. And so these are the younger rocks with the Tethyan fauna affinity. And again, they're documenting the accretion of another terrain. So I'm going to go through some of the steps here on the overhead projector. So here I call this accreted terrains, growth of Western North America. So if we remember back going to Neoproterozoic time in through the middle Paleozoic till about maybe 300 million years ago, California was a trailing continental margin, a passive margin. So remember our noonday dolomite, Johnny quartzite, Sterling quartzite, Wood Canyon Formation, Precambrian, Cambrian boundary. So here's our passive margin, Cratonic California. They're just like the East Coast is today. And so this area is in Eastern California. So much of the rest of California had not even formed yet. So anything to the west here, which will eventually be the Sierra Nevada, Central Valley, the coast, that's not even in existence yet. So we're out here still in the Death Valley region. We have to accrete or add that other material during the Phanerozoic time. Now, So you'll research the terrain and the definition of terrain, but we're going to accrete these terranes, attach them to North America. A word that I want to introduce here is orogeny. Another word we use is also orogenesis. And this refers to the mountain building event. You're making a mountain, in this case by collisional tectonics. So oro is a Greek for mountain, whereas the geni here, or orogeny, or the genesis, is the origin. So you're making a mountain, the origin or the genesis of a mountain. So let's go to the Cambrian. So this shoe fly complex, your book mentions that it's as old as 500 million years old. So that's Cambrian. And then we're going to go through the Devonian time to about 380 million years old. And so what's happening here we have Cratonic North America. So the craton is a stable interior of a continent. And then we have those marginal sediments, the trailing continental sediments on here. And then in the deeper water, we may have the shoe fly complex forming out here. But the key thing is it's a sedimentary unit that's in a basin between an encroaching or approaching island arc. In this case, it's the Northern Sierra terrane or the Eastern Klamath terrane, between this arc and the main continent. And so, so remember, we've got a Japan-type island arc, and there's one thing that we have here. We call this a reverse polarity subduction. All that means is that subduction is not going under North America. The subduction is going under the island arc, so it's a westward subduction. Once you get eastward subduction, then you start forming a magmatic arc, and we don't have it yet. We have a Japan-style island arc out here, and we'll have some reefs out here. And remember, the reefs are going to have that McLeod type corals and fusillinids, right? Now, as we move along here, the first orogeny, the first mountain building event to affect the western United States, the western Cordillera, occurred during the Devonian Mississippian time, and it really probably stretched through the Pennsylvanian. So again, this is the first mountain building event in the western United States, and it deformed the cratonic passive margin sediments, those shoe fly complex sediments. And what you did, you thrust the Northern Sierra terrane and the Eastern Klamath terrane up on top of the edge of North America. And so you're going to dock this Eastern Klamath terrane and the Northern Sierra terrane, and then you're also going to throw up that intervening shoe fly complex, right? So again, all these have that McLeod fauna affinity. And so here are the island arcs. There's also a series of volcanic rocks in the Northern Sierra called the Taylor volcanics, and they're also part of this sequence. They're being thrust over the top, and we're forming this Antler orogeny around 360 million years ago. So we're attaching the Northern Sierra terrane, the shoe fly complex, the Eastern Klamath terrane. And so here I'm showing kind of deformation. But one interesting thing that happens is, remember, we had that reverse polarity subduction. There's no subduction out over here now. So this remains a passive margin. So we keep a passive margin through the Pennsylvanian and into the Permian period, right? So here I show limestones and passive margin sediments out over here. Now, while this is forming, if we go farther out westward into the ocean, we're going to end up having another island arc that's forming. And that's the Sonoma island arcs. Some textbooks call it Sonomia, the Sonomia microplate, but there are a series of island arcs. Again, they have that McLeod affinity, so they're forming up in the northern Pacific. And so, but here again, we're seeing that reverse polarity, right? So we're showing subducting under the island arc. We see magmas melting here, producing the volcanoes here of the island arc. Another thing I want to show is that in the basin, the intervening basin between these Sonoma island arcs and the accreted terranes of the Eastern Klamath and the Northern Sierra terrane, we have another group of rocks forming here. And this is an important group of rocks that we find in the Sierra Nevada. And it's called the Calaveras complex. So the Calaveras complex, again, is going to occur to the west of the Northern Sierra terrane in the foothills of the Sierra Nevada. And so this picture I've drawn here is more like maybe like 300 million years ago, right in here. And then this one that I have down over here is a 251 million years ago, 251 million years. And so this one's showing the the actual Sonoma orogeny, the collision event where you're going to accrete or attach or dock these exotic terrains. So here I've pushed up the Sonoma and Calaveras complex onto North America. And there's a fault line, right? So the fault line that separates the Calaveras complex, Sonomia, from the older Sierra Nevada, Eastern Klamath, Shoofly complex is this fault here called the Calaveras-Shoofly fault. So again, it marks a suture zone between these two different terrains. But one interesting thing that happens during this time is that for the first time, we're going to see the normal polarity. Normal polarity. In other words, we're going to see subduction going toward the east under North America. And for the first time, we begin eastward subduction, and it's the beginning of the Andean type margin of the Sierra Nevada. We actually make the magmatic arc. And where that occurs is in this foothill subduction zone. And we call that foothill subduction zone the Maloney's Fault Zone. You can still find it. In fact, the Maloney's Fault Zone is the mother lode belt. That's where the gold is, right? And so here is a foothill subduction, mother lode belt, and then out farther to the west in this Paleo-Pacific Ocean, there is another series of arcs, another series of island arcs forming. These are the Nevadan arcs. Eventually, they're going to collide with California and make the foothills terrain and the Smartville block, right? One thing that I want to point out here is probably in the basin between these Nevadan arcs and the margin of California, you might have had a back arc spreading ridge. In fact, this is very similar to what's happening in Japan. Japan has an island arc, and between Japan and China, there is a back arc spreading ridge. And in this region, we can make a ophiolite. And this ophiolite is the ophiolite of the Smartville block. Smartville. So you'll read about the Smartville block in your text of Assembling California. But it seems to be forming in an interbasin between an arc and the mainland here. Eventually, all this will be accreted during the next orogeny, right? So if we go back a little bit, remember the Sonoma orogeny is going to accrete the Sonoma Calaveras complexes. So that's a key one right here. The Sonoma Calaveras complex is being accreted during the Sonoma orogeny. But a bunch of other things are happening. You're still forming another set of island arcs. But these are a little strange in that they have a different set of fossils. They have a Tethyan fauna affinity. So these are more closely related to the Western Pacific, out by Japan, China, Southeast Asia. So again, showing us that the rocks that are now part of California are really true immigrants. They're coming from all over the world, right? So these are coming from the Western Pacific, right? So now, and then we're also seeing this new development of a new magmatic arc here, because we're seeing for the first time subduction under North America.